I am Frederick Figueroa, taking the subject Power Plant Engineering under Engineer Punzalan. In this video, we will talk about oil or petroleum power plants. So, let's go! Before we start discussing about oil power plants, let's have a short review of what we have learned from Engineer Punzalan about power plants. What is power plant? As we have learned, power plant is a machine or assemblage of equipment that produces and delivers a flow of mechanical or electrical energy. A power plant is an industrial facility that generates electricity from primary energy. So what are these primary energies that are being used as sources? As we have learned, there are many types of energy that are being converted into electrical energy. But it could be divided into two main types: renewable and non-renewable energy resources. Renewable energy resources. These are the resources that can never be consumed to completion. It will continue to be available or be soon renewed, like the solar energy, wind, hydro, geothermal, and biomass. Non-renewable energy resources, on the other hand, are the sources that could be exhausted with a relatively short period of time, like nuclear, fossil fuels, and natural gas. This is where our main topic comes in. So, what really is an oil power plant? Oil-powered power plants or petroleum power plant is a type of fossil fuel power station which burns petroleum to produce electricity. So oil or petroleum is one type of fossil fuel. Let's have a look on types of fossil fuels then. There are three common types of fossil fuels. One, oil, which is a solid fossil fuel, and two is the petroleum or the liquid fossil fuel, and three are the natural gases. I think to further understand oil power plants, we need to learn about oil first. So let's watch a video about oil.
Oil. Oil, otherwise known as petroleum or crude, is a thick black liquid composed primarily of hydrogen and carbon. The physical properties of oil, such as its thickness, vary greatly depending on the specific combination of hydrocarbon molecules. Oil also contains trace elements of sulfur, nitrogen, and oxygen. Today's oil deposits were formed millions of years ago when dead marine organisms sunk to the bottom of the ocean bed and were buried under deposits of sedimentary rock. After subjection to intense heat and pressure, these organisms underwent a transformation process by which they were converted to oil over millions of years. This is why you may have heard oil referred to as a fossil fuel. Oil is found in underground geological formations called reservoirs. The rocks found in a reservoir have various physical properties that allow them to hold hydrocarbon reserves. Through exploration activities such as seismic, surveying, rock core sampling, and other advanced technologies, geologists locate oil reserves. Oil is extracted from the reservoir most commonly by drilling a well. Once recovered, oil is transported by pipeline, ship, rail, or truck to a refinery where it undergoes a complex refining process that creates petroleum products like gasoline, diesel, jet fuel, asphalt, and many more. Currently, the world uses oil primarily to power its transportation system and to create commonly used synthetic products like plastics and petrochemicals. The production and use of oil presents social and environmental challenges. Producing oil causes land disturbance, sometimes in environmentally sensitive areas. Oil-powered transportation systems contribute to global greenhouse gas emission levels. And control of oil resources is a persistent factor in geopolitical tensions globally. That's oil.
Petroleum or crude oil is a fossil fuel. It is the result of organic matter transforming into hydrocarbons over millions of years. Generally buried in the form of deposit, crude oil sometimes appears on the surface of the earth, which is why it has been known to man since ancient times. Around the world, oil was used as sealing material in construction and for medical purposes. But it's only in the middle of the 19th century that its consumption would explode. Europe and North America, in the midst of the Industrial Revolution, have rapidly increasing energy requirements that are mainly by coal. Interest in oil intensifies throughout the world, from the Russian Empire to Europe to North America, the first drilling location. In the United States, this caused a rush of black gold, and the country became the largest oil producer in the world. Initially, distilled oil replaces the burning of whale oil in lamps. It offers a better calorific value than coal and is easier to transport than gas. Oil consumption rises in the early 20th century, specifically in the field of transport, with the development of automobile and reconversion ship and the invasion and during the World War I. Crude oil, once extracted, is distilled in a refinery to separate hydrocarbons as needed. The lighter molecules evaporate to the top of the distillation column where the temperature is around 20 degrees Celsius. Liquefied petroleum gases are harvested and used among other things in lighters and in kitchens. Between 30 and 105 degrees Celsius, gasoline for cars is produced. Between 105 and 160 degrees Celsius, naphtha is created, used in petrochemicals in order to create plastics, synthetic textiles, drugs, and cosmetics. Between 160 and 230 degrees Celsius, kerosene is obtained for aviation. Between 230 and 425 degrees Celsius, diesel is created for cars and heating oil for domestic purposes. Finally, the thick high sulfur residue is heated above 450 degrees Celsius to form heavy fuel oil used by ships and to obtain bitumen used for roads construction and roofing. Oil was transported in barrel with a capacity of 42 US gallons, or slightly less than 159 liters. The barrel thus became the unit for setting oil prices. More and more oil deposit discoveries are made worldwide, including in Venezuela, which becomes the second largest global producer. In the Middle East, where Britain is present, Western companies seize the new market, giving a portion of their profits to the local country through royalties. During World War II, demand for oil skyrocketed, and the resources becomes a major international issue. At the end of the war, the United States signed an alliance with Saudi Arabia, and guaranteeing security of the country in return for privileged access to its oil.
To understand further the process in refining petroleum, let's watch this video.
Refining begins with a process called distilling. After oil is superheated, it becomes vapor. The vapor is fed into the distillation unit. As it rises and cools, the vapor turns back into a liquid. Using stacks of trays, the liquid is easily collected and separated by weight. The lighter and medium weight liquids require less processing before they're ready to be used in cars and trucks. The heavier liquids need more processing to become useful. A process called cracking is used to maximize the usefulness of heavy oil. Heavy oil has long strings of carbon and hydrogen molecules. Using a catalyst, these molecules can be broken into smaller chains, transforming the heavy oil into lighter, more valuable fluids. Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but their structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable, gasoline-like molecule. Blending is a process of mixing different refinery products to make finished petroleum fuels. Gasoline, for example, is blended to achieve octane standards, creating the grades of gasoline you see at the pump: regular, mid-grade, and premium, that are necessary to meet the needs of specific engine types. Treating is a process used to produce cleaner gasoline, which helps protect both the environment and our health. Gasoline molecules contain impurities like sulfur that can be removed. When the molecules are heated and come in contact with a special catalyst, a chemical reaction occurs that strips the sulfur away. These sulfur compounds are used as fertilizers and in pharmaceuticals. Nothing goes to waste in a refinery.
Let's go back to our main topic of oil or petroleum power plants. Power plants that burn oil to produce electricity is called an oil-fired plant. They are no different in general principle and operation from their fossil fuel cousins, the oil-fired and natural gas-fired plants, and are even similar to geothermal and nuclear plants in some aspects. They burn oil to heat up the water in order to produce steam. Then the steam drives the steam turbine, which is connected to the generator by a shaft, then produce electricity. That is the basic principle of an oil-fired power plant.
Basic construction of an oil-fired power plant. 1. Oil storage. 2. Burner or boiler section. 3. Chimney. 4. Steam drum. 5. Turbines. 6. Condenser. 7. Cooling tower. 8. Generator. And 9. Transformer. Oil storage is the oil tank. This is where we store the oil. Burner boiler section is where the oil or the petroleum is being burned. Chimney is where the waste gases and smoke were being released. Steam drum is where the water is being boiled to produce steam. Turbines, this is where the steam is piped to. Condenser is where the steam is being converted back to water. Cooling tower is for the cooling of water. Generator is to produce electricity, and also we have the transformer to prepare it for the grid. Now, let's talk about the basic process of an oil-fired power plant. Oil from the storage enters the burner or boiler section, and this is where it will be burned. The waste gases and smoke from burning the oil will exit through the chimney. The heat from the burning oil will boil the water in the steam drum. The resulting steam is piped to the turbines, which are connected to the generators where electricity is generated. The steam will go now to the condenser, and it will be condensed and piped back to the steam drum. Inside the condenser, excess heat from the steam is being transferred to the water and will be vented through the cooling tower. The electricity is transformed and distributed through a grid of pylons and cables.
There are three technologies that are used to convert oil into electricity: conventional steam, combustion turbine, and a combined cycle technology. Conventional steam, oil is burned to heat water to create steam to generate electricity. Combustion turbine, oil is burned under pressure to produce hot exhaust gases which spin a turbine to generate electricity. While in a combined cycle technology, oil is first combusted in a combustion turbine, using the heat exhausted gases to generate electricity. After these exhaust gases are recovered, they heat water in a boiler, creating steam to drive a second turbine.
Combined cycle technology enables power plants to generate 50% more electricity from its fuel than it would with a conventional single-cycle power system. Under this dual-phase system, two combustion turbine generators operate in conjunction with two heat recovery steam generators and a steam turbine generator. In the first cycle, fuel is burned and the resulting combustion gases power two turbine generators to produce electricity. Hot exhaust normally lost during this process is captured and routed through the two heat recovery steam generators. These units boil water to create steam, which spins an additional turbine generator and produces more electricity. Finally, the steam is discharged into a condenser, which returns the steam to its liquid state for recycling.
Advantages of oil-fired power plants. 1. Oil can be easily transported by a network of pipelines. 2. Oil-fired power stations can be built in almost anywhere. And 3. A small amount can produce a lot of energy. Disadvantages of oil-fired power plants. First, oil is a non-renewable source of energy. Second, burning oil reduces carbon dioxide, which can cause pollution. Next, much of our oil has to be imported. Lastly, producing electricity from oil is expensive compared to other fossil fuels like coal or gas. So why do we say that it can cause pollution? What are the environmental impacts of burning oil? Burning oil for electricity pollutes the air, water, and land, but some of the worst environmental woes associated with oil are linked to drilling, transporting, and refining. Burning oil to generate electricity produces significant air pollution in the forms of nitrogen oxides and, depending on the sulfur content of oil, sulfur dioxide and particulates. The operation of oil-fired power plants also impacts water, land use, and solid waste disposal. Similar to the operations of other conventional steam technologies, Oil-fired conventional steam plants require a large amount of water for steam and cooling and can negatively impact the local water resources and aquatic habitats. Drilling also produces a long list of air pollutants, toxic and hazardous materials, and emissions of hydrogen sulfide, a highly flammable and toxic gas.
Let's have some examples of oil-fired power stations around the world. Number 1. Shawiba Power and Desalination Plant. Shawiba Power and Desalination Plant is located in the South Jeddah in Saudi Arabia. It started operating in a complete phase on 2003. This is one of the world's largest fossil fuel power plant. It is owned by the Saudi Consolidated Electric Company. It has a unit operational with 14 units. The total capacity of the plant is 5,600 megawatts. Number 2. Kashima Power Station. Kashima Power Station is located in Ibaraki, Japan. It started operating in the complete phase on 2014. This is the world's largest fossil fuel station. It is owned by the Tokyo Electric Power Company. It has 9 units operational. The total capacity of this power plant is 5,660 megawatts. The unit operation is divided into 3, which has 2 1,000 megawatts, 4 600 megawatts, and 3 420 megawatts. Number 3. Collison Cove Generation Station. Collison Cove Generation Station is located in New Brunswick, Canada. It started operating on 1976. It is owned by the NB Power. It has 3 units operational with a capacity of 350 megawatts per unit, resulting to a total capacity of 1,050 megawatts. It can burn up to 5 million gallons of oil for each unit operation. Number 4. Wirinaki Power Station. Wirinaki Power Station is located in Wirinaki, New Zealand. It started operating on 2004. It is owned by the Contact Energy. The primary fuel for this station is diesel. It has a total of 3 units operation with 51.6 megawatts per unit, having a total capacity of 155 megawatts. Approximately 4 million liters of diesel can be stored on site.
Heavy fuel oil was once a significant source of energy for electric power generation. After oil price increase in the 1970s, oil was displaced by coal and later by natural gas. However, distillate oil is still important as the fuel source for diesel-powered plants used especially in isolated communities that are not connected to the grid. Also, liquid fuels may be used by gas turbine power plants, especially for peaking or emergency services. According to the Renewable Energy Institute, based on the electricity generation percentage of 2019 that was gathered as of June 25, year 2020, from the Statistical Review of the World Energy 2020, we can see that only 3.1% of the total energy consumed was produced by oil or petroleum. Even though only a small percentage in power generation uses oil as energy source, oil is continuously extracted since it is widely used for its other purposes, especially in terms of transportation. So, that's the end of our video. I hope you have learned something new. So, thank you and keep safe.